Just hearing that word already makes some people nervous.
But today, we are going to prove that trigonometry isn't something to fear. It's something to discover.
And together, we'll be your guides as we explore the fascinating world of trigonometry. Most people think that trigonometry is a mountain of scary formulas. But what if I tell you that it's actually a secret language to measure the world without even using a ruler? Look around you. The bridges, buildings, and even shadows. We use trigonometry because it helps us measure heights, distance, and even angles without directly measuring them. Today, we're breaking down the walls, from basic definitions to angle conversions and to the power of proportions. This is your ultimate guide to trigonometry. So, come with us and let's unlock this powerful math together. Let's go!
What is trigonometry? Let's break down the name. So, trigonometry comes from the Greek word trigon and metron. And trigon means triangle, while metron means measure. So, trigonometry literally means measure triangles. But before we solve the triangles, we need to understand its language. So, here are the key terms. Vertex means the corner where the two lines meet. And theta means the symbol that represents the unknown angle. Hypotenuse is the longest side of the triangle. It is the opposite side of the 90-degree angle. And opposite side, it is the side that is across from the angle. And adjacent is the side next to the angle theta. These terms helps us describe the relationship inside the triangle.
Now that you have already known the parts of a triangle, let's proceed to connect them using ratios. We are going to use the three basic trigonometric functions: the sine, cosine, and tangent. For the sine, the ratio is opposite over hypotenuse. For the cosine, we have the adjacent over hypotenuse. And for the tangent, we have opposite over adjacent. And these terms can be used as the heart of the trigonometry. Again, what are the three basic trigonometric functions? We have the sine, cosine, and tangent. To better remember them, we have the so, ka, and toa. So for the sine, opposite over hypotenuse. Ka for the cosine, adjacent over hypotenuse. And we have the toa, tangent, opposite over adjacent.
We usually measure angles in degrees, like 360 degrees for a full circle. That's what we've been used since elementary. But in higher mathematics, we use different unit called radians. Think of radians and degrees like Celsius and Fahrenheit. They measure the same thing, but they use different scales. Now, here's the key ideas. A full circle is 360 degrees, and that is equal to 2 pi radians. So, a semicircle is equal to 180 degrees, and that is equal to pi radians.
So let's move on to conversion process. If we want to convert between the two, we just use simple multiplication. If you are given degrees, multiply it by pi over 180. For example, if we want to turn the 60 degrees into radians, we just need to multiply the 60 degrees by pi over 180. So, 60 degrees times pi over 80 is equal to pi over 3 radians. If you are given radians, multiply it by 180 over pi. For example, pi over 2 is we want to turn this into degrees. So, pi over 2 times 180 over pi is equal to 90 degrees.
Now let's talk about the real power of trigonometry, the ratio and the proportion. But first, let us define what is ratio and what is proportion. Ratio is simply a comparison of two numbers. For example, is 1 is to 2. And the proportion, it is the equation that shows two ratios are equal. For example, A over B is equal C over D, which means that the relationship of A and B are the same or equal to the relationship of C and D. Now, here's the amazing part. In trigonometry, when the angle stays the same, the ratio of the sides also stays the same, no matter how big or small the triangle is. This idea is what we call the similar triangle. It means that even if you have a small triangle and a very large triangle, as long as its angles are equal, its side ratios are equal too. This is why exactly trigonometry are so powerful in real life, because its constant formulas allow us to measure things that is hard to be reached. Example, the heights of the mountains, the distance across river, and even help engineers design bridges.
Remember this important idea. If the angles are the same, the triangles are similar. And if the triangles are similar, the ratios of their sides stay the same. Since the triangles are similar, we can set up a proportion. Now, let's solve this step by step using cross multiplication.
For the small triangle, opposite side is equal to 3 and the adjacent side is equal to 4. For the large triangle, opposite side is missing while the adjacent side is equal to 8.
Let's look at two triangles that have the same angles. When triangles have the same angles, we call them similar triangles. That means even if one triangle is bigger, their side ratio is still the same. Now, let's simplify the given values.
Multiply diagonally. So we have 3 times 8 equals 24. 4 times x equals 4x. So we get 24 equals 4x. Next, divide both sides by 4 to isolate x. So we have x equals 6. So the value of the missing side is 6.
Now that we know the basics of trigonometry, let's answer an important question. Where do we actually use trigonometry in real life? Trigonometry is not just numbers and formulas. It helps us measure things that are difficult or impossible to measure directly.
For example, we use it in measuring the height of buildings. Instead of climbing a building, we can stay on the ground and use angles to find its height. It is also used in navigation, like in ships and airplanes, to calculate distances and directions. In engineering and construction, trigonometry helps in designing structures like bridges, roads, and buildings to make sure they are safe and accurate. In astronomy and space science, it helps scientists measure the distance of stars and planets. And even in video games and animation, trigonometry is used to control movements, angles, and realistic graphics.
I hope you learned something. Thank you for watching.